How it's done, CNC machining. SolidWorks is a 3D modeling system where many CNC projects get their start. We can select different geometry, shapes, sizes, depths, and create a model to be used later in our CNC process. We can even associate sizes to everything, so that way the CNC machinist knows the sizes and positioning of all the part features. Now we have a completed 3D model. We use Mastercam to take the 3D model and program all of our tool paths. Here we're adding a new tool path for all the holes. Pick the drill cycle and give it a name. And select all of our points where the drill will go. We can change the order of these tool paths to make it more efficient on the machine. Now we select the tool that we're going to use. For this we're going to use a drill. We now adjust the speeds and feeds of the drill so that it runs as quickly as possible while keeping tool life in mind. And we add the cut parameters, which sets it to a tool depth, and this is where we set how deep that drill is going to go. We add a little tip compensation and check the planes and turn on the coolant. Now that our part is programmed, we have to cut the raw material to size. This is a horizontal bandsaw. We'll measure the part and set the stop so we can cut multiple pieces. Now we need to select our tooling and load our tool holders. There are many different tool holders for many different applications, and many different tools for many different jobs. Load the tool by putting in an appropriate size collet. Make sure it's sticking out far enough, and tighten it down. It's time to load the tool into the machine. First we remove the existing tool and load the new tool. Now we need to set the height of the tool so that way the machine knows exactly where the tip of that tool is. And now that tool is programmed in. Now we need to locate the part in the machine so that the machine knows where exactly it is and where it's going to cut. We must ensure our vices are tightened down securely so that the part does not move in the force of the machine. Using an indicator, we can ensure that the tool is centered on the X and the Y positions. We also need to set the Z height of the part so that way the machine knows exactly where the top of that piece is so we can avoid a crash. And now we're ready to run our machine. The program is also loaded, and now it's time to run the program. Use the face-off tool, simply just making sure the top of the part is nice and flat. Change tools to an end mill, which is going to shape our part around the outside. And switch to the drill, which is going to drill all of our holes. To the end mill, which is going to give us our counter bore. And our drill for the center tap. And now it's time to run our chamfer tool to give the part a nice bevel all the way around and chamfer all of those holes. The operator has stopped the machine to inspect the depth of the hole and to determine why the chamfer did not apply. After a quick program update, we're ready to run again. Rerun the tapping drill and our chamfer. Double check that the hole is all the way through as needed. Now we can run our tap. It's time to inspect our part. We're using gauge pins here to determine that all the hole sizes are correct, and a caliper to determine the part size is correct. Some parts require finishing it manually. This one requires us to use the drill press to chamfer the back side of some of the holes. And there we have it, a finished product. Now the part can go through full quality control to ensure everything is as expected. Quality control tools such as micrometers. There are many other manufacturing processes that could be used, such as tumbling or burnishing parts, which will basically remove most blemishes and give them a nice even finish. CNC lathe operating, which is very similar to the mill, but instead we turn the part instead of turning the tool. Surface grinding, outer diameter grinding, and inner diameter grinding.